The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome. My name is Eric Coleman with IIST and I will be the moderator for today's webinar, Identifying and Executing the Most Important Tests by Clenice Cheney. We're excited you're able to join us today. Set aside an hour to attend this webinar. This webinar is one of a series of free webinars to introduce the topics as well as the presenters of the upcoming PSQT conference in San Diego, California, August 14th through the 19th at the Sheraton San Diego Hotel and Marina. PSQT is the only conference that focuses on practical best practices in every aspect of software quality assurance and testing. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To learn more about this exciting conference, visit psqtconference.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is also being recorded and will be made available for viewing within 48 hours at psqtconference.com. At the end of today's webinar, you'll be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Clenice Cheney. Clenice?
Hello, and welcome to Identifying and Executing the Most Critical Test Cases. This presentation is an overview of a full-day class that will be taught at the conference in San Diego. The course is based upon the work of Marnie Hutchinson, and there's a text, Software Testing Fundamental Methods and Metrics by Wiley Publishing Company that lays out the core fundamentals of the methodology and approach for the critical test methods. So pretty much for the conference today, or for the presentation today, we'll be covering at a high level 5 of the key topics in the course. A little bit of discussion about why the need for a most important test focus, and then how do you initiate and get started on a most important test focus strategy, and then a little bit about coveraging and how to identify those important areas of your application under test so that you can design a test strategy that is based on those critical test areas. And then taking a look at paths and data to further refine your strategy so that, again, you're focusing on the most important data, the most important paths that need to be executed for the application under test. And finally, just a little bit of information about managing the most important test strategy overall. So, since this is a class about learning how to test the most critical aspects of the system, in the end, the most important thing for us to consider is that we're looking at testing for quality. And testing is a quality control activity, so we're trying to control the final output or quality of the product by engaging in an activity known as testing. So we're trying, again, to control that quality, and one of the things that we know is that we don't want the bugs or the user experience of the end customer to encounter as few bugs as possible. So we know that testing isn't the best method for controlling quality. It can't prove or guarantee correctness. There's no method out there that can guarantee correctness, but testing can only increase our confidence that the system will usually perform without failure. So that is the target for most of us today in terms of testing, except for those of us in some healthcare areas where people might actually die, and so we have a slightly different end result in terms of our expectations for testing. But since testing can't prove the absence of defects, it can only prove that defects exist. So we want to be able to come up with a strategy or focus to really demonstrate whether or not the defects do exist in certain parts of the code. So we know that we can't test a system completely because of the complexity of a lot of the applications that are under test right now. There's just too many paths to the program to be able to test every single path and every single scenario to ensure that you've got adequate coverage and you've increased your confidence. So what is it that we can do? So we can look at, and this presentation will talk about different things that we can do in terms of that test strategy so that we can increase our confidence that The strategy that we're utilizing has executed tests in the most important and the most critical areas, and so therefore our confidence level that when it goes into production it will perform with a limited amount of defects or problems is what we are looking for. And so one of the things that is important is looking at some of the other ways besides testing that can be used in your strategy that would increase your confidence level. So we know that formal design and inspections can give us a confidence level of 45 to 68% in terms of identifying defects, which is the goal of testing, to be able to find bugs. We know that formal software testing actually has the ability to only identify 37 to 60% of the defects. And if you've got a formal quality assurance process in place, then you're looking at 32 to 55%. So clearly, some combination of these strategies is what you want to include in terms of your focus for detecting bugs and ensuring that you've got adequate confidence for the potential failure of that product. So even though we are talking about testing today, specifically in terms of that part of the strategy, we want you to be aware that that is not the only part of the focus that you should have in terms of increasing your confidence that the product will ultimately work well when it goes into production. So one of the things that we want to do with this most important test method is to help us to really identify the areas that need critical attention. I like to call them my risk focus areas. And for me, that means that I've identified the areas that are critical or higher risk of failing so that I have designed a specific targeted test strategy to ensure that. So what's the information that I use to come up with those high-risk potential failure areas? One of the areas is to look at defect clustering information from your previous versions of the product or your previous other applications, so that we do know that defects tend to cluster in small portions of the application. We know that 50% of the errors may be in 5% of the code. We know that generally the statistics say that 60% of all code may be error-free. And so when you look at some of this information, this is input into our most important test strategy. So those of you that are testing in an area where you are releasing a product that has previously been released, then part of your input into your most important test strategy is to look at the data about your defects and test failures that occurred in previous versions to see whether or not you can target those error-prone errors, those particular areas where you had a lot of failures previously, and then that would go into your area as potential product failures or risk areas for a more critical, a more important focus for this new testing strategy. So defect clustering is an input value into creating a most important test strategy focus. Another information piece that is a part of your strategy is understanding different expectations. For instance, I'm working on an Agile project right now that they do a really good job and a very effective job of unit testing at the team level. And so we have a product owner, we have the product team, and we've got an ultimate customer. So each one of those groups have different expectations of quality or what's important to them. And so finding that information early on in the project was important to coming up with a strategy that was ultimately decided on in terms of priority for testing. For instance, when I talked with the the technical director, the technical lead for the development team, and I said, you know, what are the things that worry you most about this product going into production? And so he said, you know, the thing that worries me is that we're going to pass measures that should have failed, and we will have failed measures that are passing. So this application is evaluation clinical quality measures. And so based on that description, then I asked the product owner. The product owner was more concerned about ensuring coverage and traceability of all of the user stories to some kind of passing kind of test. And so I ended up with a test strategy that looked at the high-risk areas and the key concern from the technical perspective, but also was able to provide information and confidence and assurance to the product owner that there was some traceability relative to the user story in terms of the testing. So what we have on the screen here are just some of the statistics to give you an idea of how important some of this information is, because it affects the kind of testing that we do and the type of testing that we do, and often how much we test certain areas versus another area. So we know, for instance, that 39% of consumers that speed is more important than functionality. So if that is true of your target customer base, then clearly that indicates that some performance level testing would have what, a higher percentage than, in terms of the testing strategy potentially, than a lot of testing that just verifies that yes, the requirement said it should be blue, and yes, we checked and it was actually blue. There are lots of performance expectations in terms of load testing, in terms of web pages. So 47% expect the web page to load 2 seconds or less. You know, we know about the abandonment rate of web pages if they take more than 3 seconds. Low performance and unreliability, inconsistent performance has a lot of adverse impacts in terms of from a business perspective. Right now, security and protection is extremely important. So this list is not an exhaustive list. You will find that the expectations, those what we call divergent customer expectations, will have some wide variability. For instance, in my particular one person's looking about traceability, other person's looking at making sure we don't have failures in the actual evaluation of those measures. So because of that divergent view, you want to ensure that you have an understanding of what they are and that they are a part of the consideration. They're an input and a factor that's considered when you begin to come up with your most important test focus strategy. So one of the other areas that is also critically important when you're trying to input into determining your most important test focus or test strategy is to look at risk. So we know if there are different divergent expectations of quality, and testers need to know what those expectations are to ensure adequacy of the testing. It's one of the really critical aspects of the most important test strategy is to understand the impact that product risk also has in terms of coming up with the appropriate strategy for the critical test. So we need a systematic way to begin to know and to focus on testing the most important paths or parts of that project. And we understand that you can have last-minute changes, particularly if you're testing in an agile environment, but in the end, we know that there are 2 factors that are important in identifying potential product quality failure risk. And so when I talk about product quality failure risk, I'm saying that we are concerned about the potential risk that the product could actually fail in, say, security, fail in, say, performance, fail in terms of measuring a clinical measure correctly. So, you know, if we look at traditional risk management, we look at the probability that you could have or likelihood that a risk could occur. In this case, we're going to be looking at the probability or likelihood that the product could fail in terms of security, fail in terms of calculating a measure, fail in terms of performance, in terms of load and reliability. So probability or likelihood of the product failing is one way to evaluate potential failure points within the product. The other one is to look at the impact or damage or harm. So again, from a traditional risk management kind of perspective, this isn't a change to how risk management is traditionally done. Traditionally, for project risk management, we ask people to identify what could go wrong potentially on the product, the likelihood or probability of that occurring, and then we say, and if it actually occurred, how bad, how harmful could it be? So we're going to be using those same concepts today in this most important test strategy, because a significant part of your evaluating and coming up with what are the most important tests resolve around where do you think the product could potentially fail, areas that are more complex, areas that have the most changes in the particular product that's being developed. So there are lots of different factors that we would consider or evaluate or look at to come up with those areas that have a higher likelihood of failing and or have a high impact or harm or damage should they occur. So in addition to looking at the divergent customer expectations for quality, what are they really hoping or expecting for this release? Looking at the potential clustering or areas of defect patterns potentially. We also will be looking at product potential failure points as an input to helping us to figure out in the end what is the best test strategy that we can come up with to increase our confidence of a low percentage of failure of that product when it goes into production. So when we talk about the most important test method, this is a method that is designed to answer questions. And some of the biggest questions to answer for us is, if we can't test everything, what must we test? And this is a common denominator for most testers. Just last week, in my Scrum meeting with the product team, they said, oh, Chinese, we had planned for you to have 3 weeks of testing for this final build that's coming into prior to production release, but we just had a request from another group, and we might have to slip the date by a week. Naturally, we can't slip the date. We're going live on July 28th. Can you get the testing done in 2 weeks? So the age-old question to testers. And my answer was, yes, I can test in 2 weeks. I have employed a risk-based testing strategy. And if I had 3 weeks to test, or 2 weeks to test, or 1 week to test, I would still be using that strategy. My strategy is to start with the most critical areas of the product and to continue down that path, so that if we run out of time and I end up with 2 weeks of testing, then I will be able to tell you at any point in time what risk I have tested and successfully feel that I'm confident that these risks no longer exist in this product. And I can be able to point out, where I am based on risk, because I have prioritized my testing so that the most important tests are executed first. And the way that I got to that strategy is to evaluate a lot of the things that we just talked about: the customer's expectations for quality, the risk assessment, looking at the product and its potential areas of failure, its complexity, and etc. And I also did look at defect trends from prior releases to see if they could point me in the direction of error-prone kind of modules, so that that input came into the strategy, so that regardless of the time that I have, yes, we can get testing done. You may have different levels of confidence at the end depending on how much time we end up having. So that is the key point of the takeaway for the class today, is that we are working on the assumption that testers almost never can test everything. And so, but if you can't test everything, that you have an effective test strategy, and the most important and critical tests have been identified, and so you are working from that perspective in terms of your strategy. So there's some other questions that can come out and be answered using this most important test method. Many of them will not be covered in this 1 hour session, but I bring it up because you can do a search on Marnie's book and I think there's even an e-version that's out there, but using this method, it is an effective tool for helping you to determine how long will the testing effort take. It will help you to monitor and track and keep on your schedule, especially during the planning perspective. It definitely can give you a means to coming up with how big is the testing effort for this particular application that's under test. And it will certainly help you to identify which tests to run. So of the questions that are listed here today, the two that we'll cover are how to identify which tests to run, and if we can't test everything, what must we test? So those are two of the strategies or questions that you will provide some information about how to do that as a part of this presentation. So on the screen you see the MITS process. So it's an 8-step process. Step 1 is that you take a look at the assumptions. And I'm a big person on taking a look at my assumptions because in the day before, I was using a very standard kind of approach to a software test plan. And so I had some generic kinds of assumptions, and they were assumptions like the product will be delivered on time, the product will work when we get it, that you won't click on it and it immediately fails. So there were a series of assumptions, but once I began to look at and employ risk-based testing, it became very obvious that if there were assumptions that were important enough to list in a test plan, I had to ask myself, well, what if that assumption was wrong? So what if the code doesn't work when I get it? What if the code isn't delivered on time? So the possibility that that assumption could fail or not really be correct became a risk. And some of the risks were risks that I had to manage as the test lead. Others of the risks became potential areas that helped me to identify what areas of the code needed critical or more important attention from a test perspective than others. So it's very important that you state your assumptions, but also that you evaluate the assumptions and ask yourself, what if this assumption were to be proved wrong? Would it have an impact on my testing? And if the answer is yes, then you just identified what? A risk to the project or the product in terms of potential failure points for it. So once you've done your assumptions, then you begin to build a test inventory. And I'll give you some more information on it going forward, but at a high level right now, the test inventory is the potential list of everything that could be tested. So the interesting thing with my answer to the question that the developer asked me about, well, suppose you end up with only 2 weeks instead of 3 weeks of planned testing, is that I do have an inventory of tons and tons and tons and tons of tests. And depending on the time, almost some degree of that of them will be covered. So we're going to talk about that test inventory coming forward. Then you do your MITS analysis, and that analysis includes some risk analysis of looking for probability of failures within that code, and looking for if it were to fail, in addition to the likelihood of failure, the harm or damage that it could occur, and using that information to help you to do what? Prioritize or identify what focus areas or most important areas of the code that need to have a targeted test strategy. Then fourth, you're going to be using that information to estimate your test effort. I will show you a screenshot of the spreadsheet that can be used for this calculation. I will make it available to Eric, and so he can send that spreadsheet to any of you that are interested in it. We will not cover it in depth in this 1-hour session today, but the estimating approach, that is a spreadsheet that will come up with a calculation for estimating the test effort. And so you would use steps 1 through 4, which I call your planning activities, to then negotiate your resources, and then by the time you get to step 6, you've got your strategy. You've got your most important test strategy. You've identified focus areas. Now you have to begin to build the test, and you have to decide what paths, what data needs to be tested, what the multiple paths or scenarios in the product, which ones of them would need to be tested first or second or third. Then you conduct your test, and then you measure the performance, and that's pretty much the process in whole. So the focus today is going to be on step 2. I'll talk to you about how to build and create and come up with that test inventory, and we're going to talk about the analysis, the risk analysis of looking at the product and coming up with a way to calculate what's included in the scope of your most important test strategy. So, in my real class, I get a chance to ask people to answer this, but so I'll pose the question and answer it myself. So there's a riddle. Is it possible for test coverage to be sufficient, but for the testing effort not to be? So let me repeat it again. Is it possible for test coverage to be sufficient, but for the testing effort not to be? So when we look at these two factors, when we're talking about what coverages of the potential tests that are planned, how many of them are executed, coverage could be, from a product perspective, of all the potential requirements, user stories, statements, paths that are possible in the application under test. How much of the testing that you plan to conduct will cover those paths, user stories, and etc. So that's what we're talking about in terms of coverage. So when we talk about the testing effort, though, we're including all the activities that go into actually successfully testing an application. So that if we had a scenario where we've got hundreds of tests planned, but our test data strategy was faulty, and so we would have had adequate coverage planned. We've done lots and lots and lots and lots and lots of tests, but however, the test data that we were using was not adequate, correct, or appropriate for the test, and hence we had failures or tests that failed that shouldn't have, and bugs that were written or things that were working correctly because the data was incorrect. So the testing effort could not be successful, although the coverage was sufficient. So the important part of this concept for the presentation today is that we're trying to give you both of these elements right now using the MITS. So we'll be focusing a lot on the coverage, but we're also going to be including those other elements to ensure that not only do we have adequate coverage, which is an important part of a most important test strategy, we also have to ensure that the other elements are in place so that the effort overall is successful. So the key decisions that we often have when we're talking about test planning, and I'll be very frank with you, right now I don't write test plans the way that I've written them 25 or so years ago. I write a test strategy, which is a much, 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 much smaller document, but it's more important because, at least to me, it's more important because it lays out exactly what the approach is that I plan to do to ensure adequate testing for the application. And so hence, it's not just like in traditional test plan, the test approach is like a section of 10 or 12 or 13 different other topics that are a part of that test plan template. And so I write to a test strategy. So to me, one of the most important things that I need to do very early in the strategy is to start figuring out of the potential things that could be tested, what should be tested. So on the screen here, this to me is the dilemma, and this is the dilemma that we'll be working to solve with the most important test method, is that if you have an inventory of tests that are available to test. My current inventory for the application that is under test for the production release at the end of this month, I have hundreds of tests that are available to test. And many of them have been tested at different points through the last several months as we got iterations of the product was delivered to testing. But right now, at the point that I'm at in the project, where a new release was delivered last night, and I have approximately 3 weeks or so to test. So of what is available, what should be tested. And so this is what your most important test strategy And then this is where the answer to the question that technical lead asked me, how much of the testing can you get done, Chinese, if you have 2 weeks versus 3 weeks? And so to me, testing always has these 3 potential buckets, decisions, quandaries. We have what is available to test, but we often assume that everything available should be tested. And the MIPS strategy is not saying that. The MIPS strategy is saying this is what is available, but this is the minimum set that should be tested. And then potentially a subset of that could be what can be tested or could be tested. So that is the approach, that's the foundation for the MIPS strategy, is that we're going to focus on creating in the very beginning an inventory of what could be available to test, and using that input that I talked about, the customer divergent expectations of quality, looking for potential failure points or risk in the product, looking at different paths or scenarios, then we're going to come up with what should be tested, and then hopefully we have enough time. What should be tested is what will be tested, but we also need to consider whether or not there is a smaller subset of what actually can be tested. So, and that you still will be able to have confidence about or information about the potential release of that product and its potential to fail once you go into production. So when we talk about the test inventory, right now mine is in Excel. It's a complete enumeration of all the tests of all the types that could be done. So it's the path test, the module test, your data test, your end-to-end systems test, your functional test, installation test, environment test, configuration test, regression test, etc. So that is the inventory of all the potential tests. I like to group them in categories. It just makes it easier. So I have functional tests, and I have scenario tests, then I have performance tests, I've got failure tests. So I do group them because that grouping helps me in terms of looking at risk and other items. Yes? I thought I heard the microphone. No? So the inventory then is a complete enumeration of all the tests, of all the types. And you're not going to build all of these tests, but you want an inventory to start with, because that's going to help you in your calculation of what should be tested and what could be tested. So part of the inventory then, once you have your inventory, is that then you want to begin to look at some prioritization for that initial inventory. And the risk analysis is the technique or the tool that helps you with that. So 3 questions can be answered when you're trying to mitigate some of the risk. So you have to estimate, 1, the probability that the risk or the event will occur. And so you want to look at it from the perspective of some kind of quality like percentage. So you can use severity of a risk in terms of loss of life. For instance, in my particular case, the clinical measures, we associated a very high severity of risk for any of the measures that correctly evaluated a measure as passing and it failed, and it actually should have failed. So we're looking at the probability or likelihood of that risk or product failing, and then we're looking at the impact or harm of it. So the MITS risk analysis is very traditional in the sense of traditional risk management. So we're looking at taking a look at the product, its features, its complexity, the quality characteristics, the expectations for the customer, and prioritizing that initial inventory based on what's the likelihood that we could have failures in these areas of the code, and if they were to fail from a customer perspective, what would be the harm or the damage that it occurred. And so using that list, then some of your areas are going to have what? Low risk, and those are going to be lower in the most important test inventory than the ones that are higher risk. So that priority, that probability and harm calculated gives you some kind of number. You know, if you have a score of 5 and 5, then the priority is 25. So those features, those areas of the inventory that have high risk scores would be at the top, and the ones that have low scores would be at the bottom. So it's a very basic thing, but basically what this analysis does is the basis for your test coverage. One, the total inventory is all of the potential things that could be covered, but then within that you want to select the most important ones from a coverage perspective, because you want what? The testing effort to be successful. So you utilize the risk index based on probability and severity of failure, and you use it throughout the process. So as you begin to execute your test, you want to evaluate whether or not your assessment of that risk was correct or not. But basically, this risk analysis, this MITS analysis, helps you to identify what needs to be done, and so that you know that in the end that you have a test strategy that will effectively assess this product and give you confidence that it is going to actually work. So this is the spreadsheet that I talked about. I'll, at a high level, go over it. So we've got inventory items. So these are different elements within the system. We've got test IDs that are associated with it. This ranking is based on the risk analysis here. And so then we've got percentage of coverage, and these are calculations in that. But in the end, so we will end up with a total of all the potential tests, and then you'll have a percent coverage, so that if you look at the bottom, we have what, 72%. So depending on what your coverage or what your quality requirements are, you can have a percentage of coverage. I want 80%, I want 70%, 60%, but you need to come up with the line in the sand. But this spreadsheet will help you to calculate based on the total items in your inventory and the risk analysis of the items in your inventory, which items need to be included from a coverage perspective, and what percentage of all the things in the inventory need to be tested. So again, so the spreadsheet will be available to you, and it's pretty much self-explanatory once you take a look at it. So once you've got your inventory in place and you've come up with that, of your total inventory, 60% of them have been covered. And let me go back real quick. Over here you see the number of tests. So it helps you to identify what percentage of the 11 tests need to be done for purchase option. There were total number of tests of 11. So based on the risk rank, we have a calculation for how many of those percentage of the tests need to be executed in order for you to feel confident. So each one of your feature inventory items will end up with a total number of tests and the smallest number of tests that could potentially be executed for you to have confidence from a coverage perspective. That's pretty much how the spreadsheet works. So once you've done that, then you have to figure out, so I had 11 tests for this particular item. I'm going to be executing 6 of them. Which are the 6 that need to be executed? So this is the further refinement of your test inventory. And we use that by designing and selecting tests. We're going to be looking at several approaches to it. One of the approaches is to look at your functional paths. So when we talk about functional paths, we're talking about the logical paths throughout the application. And those paths, some of us think of it more from a business scenario, but we're looking more at a logical system level path. So functional paths are one way for you to, if you know the total number of paths in the application, then you come up with a percentage of those paths are the most commonly used paths, and that allows you to do what? Reduce the testing. Can you test every path? No. But using the path analysis approach, you can identify how many of the paths you should test, and that should be some subset of the total paths. So if it's 100 paths in the application, then some subset using this approach will identify the smallest number of paths to be tested to, again, give you confidence that the application has been adequately covered from a path perspective. So you can use menu maps to help you get a quick understanding of the paths in the application. You can use a logic flow map if you have that for your application. You can use cases to help you to get a sense for quickly identifying what the path of the scenarios or the use cases in an application to come up with a total number versus the subset that need to be executed. But in the end, path analysis is a very sound technique for helping to support or identifying the minimal number of tests that need to be executed. So again, in this 1 hour of the class, it's not possible to show you how to test or how to do that functional analysis, but if you do a search for path analysis, there's lots of techniques available to help you to understand how to do that. But you can definitely look at, do a search for use case analysis, menu analysis, and path analysis. And each one of those three are areas to help you fine-tune the inventory and create a subset of the total inventory so that you have a smaller number of potential tests to do. So path analysis, again, is the tool for testers who are required to test applications that have use cases, the use case analysis for use cases as requirements. So you can take a look at, evaluate the use cases that are present, and then come up with a subset of those from that analysis as to the minimal set of use cases that need to be executed from the total inventory are possible. But in addition to the use cases, menus and GUI layouts is another means of identifying paths through a product. So summary, if you have an inventory, you can use either your use cases or your menus or more formal path analysis technique. Either one of the three are means to help you to come up with a smaller subset of products that are tests actually that need to be tested. Then the next element that we want to introduce is to look at the next level of tests. So you've got your, let's go back, you've got your inventory of all of your potential tests. Now you've done your path analysis. Let's say you did use case analysis, and you've identified that of the total number of use cases you have, these are the most important use cases to execute from your testing. So you create tests based on those use case scenarios. So now we want to look at a further refinement. We all know that most of the applications that we have multiple data parameters. And so the next level of selecting tests is which of the data elements that need to be tested. For instance, on the application that I'm working on right now, we've got multiple browsers. And so which of the browsers are more important than other browsers to do your actual testing on. So we're looking at the techniques that we'll be using for you to further refine is you can do BVA, which is boundary value analysis. So that's the concept where if you've got a numeric field and you've got the field would accept values from 1 to 1,000. So our boundary value analysis technique says that you pick one at the very beginning, you pick one at the middle, and you pick one at the end, and you pick maybe a negative on each side of that, and instead of testing 1,000 different data elements going in, you test at the boundary. So that is a way of reducing the total number of tests that need to be executed for particular fields. You can use that same analysis for non-numeric fields. The other technique is decision tables. Decision tables are another means of further refining your particular inventory of tests so that you get down to a smaller number of tests that need to be done. We've got state transitions. So we're going to walk through very quickly each one of those to just give you a high level of it. But again, each of these techniques are provided detailed information on the internet, so you can find a lot of the how to do them by doing that search. So in terms of equivalence partition right here, we've got a scenario where the customer is eligible for a discount if they're at least 18 years and no older than 56. So we show you how you do that equivalence partition right here. So you've got under 18, that's an invalid partition. So we're going to have some tests where we're going to do some values under 18, and they should do fail, because they can't get the discount if you're less than 18. And so the valid range is 18 to less than 56, and I've got a bug here, it should be greater than 18. And then an invalid is greater than 56. So if you were coming up with your test data, the way that you would do that, you would have some values under 18, one or two. You would test a couple values within the mid-range, and then you would test a couple over the 56, but you would not test every number between 1 and post 56. So again, it's a technique to help you to reduce the number of potential tests that you would execute from that inventory that you selected. Then boundary value analysis, what we had talked about a little bit before. This technique is that, again, you're looking at 4 fields. Most of the time it's numeric fields, but you've got a wide range of values that could be put in. And so boundary value analysis says that you would look and get the typical number or value. You would look at the maximum value. You would look at the minimum value. You would look at one value right in the inside of the range. You would look at a value right in the outside, and you would create some obvious failure ones, so that if the value expected a positive number, then you would throw in some negative numbers. But again, this allows you to do substantially reduce the potential values that you would actually test for each one of your input fields using this technique. Then we've got decision tables. So when we're talking about the decision table, the techniques of equivalence partitioning, which we just introduced quickly, and boundary value analysis are often applied, again, to help you to come up with specific situations or inputs. But sometimes, if there are different combinations of inputs that result in different actions being taken, this can be a lot more difficult to show using equivalence partitioning or boundary value analysis techniques, because they're more focused on the user interface in terms of what input values are going in. So there are 2 other techniques that you can use to, again, reduce the number of tests that you are going to include in your what should be tested, and that is decision tables and state transition testing. So we're going to talk about decision tables today. We're not going to talk about state transition because we really don't have time in the 50 minutes to go over that. So the decision table is a good way to deal with combination of things. And so sometimes it's referred to as a cause-effect table. And so the reason for this is that there is associated logic, for you know, if you do this cause, then it will give you this effect. So they provide a systematic way of stating complex business rules, which are useful to testers when you're trying to come up with making sure that, you know, if you do this, you expect to see this, and you've got adequate coverage of the decisions and different combinations that result from that particular requirement from the business perspective. So they can be used in test design, whether or not they're used in the actual requirement specification, because they help testers to explore the effects of combination of different inputs and other software states that correctly work on those business rules. So again, we don't have an example of what the decision table looks like, but these are the techniques that will help you to do what? Again, refine down. So we're at the point now where let's talk about pulling all of this together. So when we talked about MITs, in the very beginning we had those first 4 steps. One, you looked at your assumptions, and I talked about making sure that your assumptions, you really evaluate if that assumption is true, false. Maybe that should be a risk that I'm going to manage to. But then once you've done your assumptions, then you come up with the total enumeration or inventory. The way that I do the inventory based on test objectives, not on actually writing tests. So the application that I'm currently working on, I've got user stories associated with it, and then I've got test objectives, and that is the total inventory of potential areas that would be tested. And then once you have that inventory, then I did a risk assessment of that inventory. And based on the input that I had from the technical lead in terms of these are the areas that I am most concerned about is in terms of measure failure, and the product person being concerned about traceability, that I did a ranking of all of the objectives in that inventory so that a subset of that total inventory then began to be the most important tests that need to be executed. And so then from that, then I did a further refinement. For instance, I had some multiple conditions. I mentioned before we had multiple browsers. I also had multiple what they call modes or configurations that the application could be in. It can be in demo mode, it can be in pre-certification mode, it can be in public certification mode. So looking at that, I needed to be able to evaluate what was the testing that needed to be done for each of the modes from a minimum set of coverage to a maximum coverage. So again, using the techniques of use case and path analysis, using equivalence partitioning, I did do a decision table, so I was able to come up with an inventory of what should be tested for the release that is going into production in 2 weeks. So using this approach, you can use this MITS approach also with Azure projects. So again, you answer the question, what do we know about the project? So the test inventory will come from your requirements, your user stories, etc. But in the end, it should be the list of test objectives at a minimum that you feel would adequately address all of the particular requirements that are business functionality that is going to be in that release. And then how many tests are there in that test inventory? So the inventory should enumerate everything to test, but using the spreadsheet that will be provided for you and the formulas after you do your risk assessment, then you're going to come up with basically 3 different elements. You will come up with the total inventory, but you will also have calculations for what the minimum, what should be the optimum of what should be tested, and then there's going to be an absolute minimum number of tests based on this inventory and this risk assessment that should be tested. And so that is really a very helpful thing, because you can clearly say, well, you know, I've got a total inventory of 350 tests, but 180 of them should be tested if we have all the time that we need to for the effort. but we can get by with a minimum of 120. And that 120, based on your risk assessment and adequate inventory, are clearly the most important tests that need to be done to give you the confidence that you are looking for. So you are using this strategy, whether it's an Agile project or not, if you know the basic information about the product and you use that to build your test inventory, and then you use the risk analysis technique of looking for potential failure points and estimating harm or damage, you use that information to come up with a ranking of the inventory, then that will give you, if you can't test everything, what should we test? You would have then the total inventory, what should be tested and what could be tested if you run out of time using that ranking criteria. So you have the how many tests should be tested, and then if you need a further refinement in terms of the input parameters for multiple business scenarios or multiple input parameters, then you use things like the partitioning, boundary value analysis, path analysis using use cases or menus to help you further refine and further identify that set of tests that need to actually be executed within the application under test strategy. So that is we're 5 minutes before the end of the presentation. I'd like to see if we have any questions at this point.
Thank you, Clenise. While we're waiting for some questions to be submitted, can you just quickly just do one or two quick questions that you typically get when giving this presentation?
I think the biggest question I get is how to come up with a good inventory. And I found that if you're using user stories or use cases, the inventory is very quick to do. If you're in a more traditional mode where you've got lots and lots and lots of detailed requirements, then it gets pretty tricky. And I found that the best technique for then coming up with an inventory that's not too large and too burdensome to handle is to do your requirements from a functional or module type perspective to give you something that's more manageable. Because the application that I'm currently testing right now has, I've got like 260 user stories, but that also includes user stories that are bugs, but that's a small application. For those of you that are using much larger applications, then you still want an inventory that is manageable. And so using user stories or use cases or even modular menu kind of component is a way to actually manage that inventory so that it's manageable, and that will still allow you to have that feel where you have how many tests. So if this is a very complex module, you could have, 100 tests or 100 test objectives, but you don't have to list every individual requirement in that component in order to have your inventory be successfully reflecting the complexity that is represented by those multiple requirements. So coming up with the inventory is one. The other thing is some of the techniques, I think business value, the partitioning is fairly simple. I have found that when you have very complex business scenarios that sometimes you have to look at the combinatorial pairwise testing techniques, and that can get a little complicated. But NIST has some very good tutorials on it, so I have found that people that have really complex situations where there are multiple possibilities that need to be tested, they know that they can't, and coming down with that. So using the pairwise combinatorial testing technique, and they have open source tools that are out there that help you with it, is the scenario to go to. So that is one question I see a lot. If you have something that's very complex, how do you manage that? And you manage it using the combinatorial tools that are open source that are out there, because trying to do it in your head in a spreadsheet isn't a feasible alternative.
Wonderful. Thank you, Clenice. Looks like that's all the questions that we have today. So I want to thank you for your time today, and I want to thank everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. Be sure to join us for the next webinar in the series, When Agile is a Quality Game Changer, Predictive Forecasting for Defective Profiles, on July 14th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to psqtconference.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day. Thank you, Clenice.
Thank you, and remind them that the Excel spreadsheet will be available. I'll send it to you today.
Wonderful. Thank you, Clenice.
Bye.